Hi students, welcome to Chemistry Online. In previous class we discussed about classification of a periodic table, about Dobereiner law of traits and Lothar-Meyer law of octaves, then Mendeleev's periodic table. Today we are going to discuss MOSELEY'S equation. MOSELEY'S equation. MOSELEY'S equation. Why? What is the need of discussing MOSELEY'S equation means to rectifying the defects in the Mendeleev's periodic table. So the need is arise to discuss MOSELEY'S equation. In 1913, the man Henry Moseley given a relation between nu and z. So given a relation between nu and z. So nu equal to frequency, characteristic frequency of the X-ray spectra line. Nu equal to characteristic frequency of X-ray characteristic frequency of X-rays, then Z equal to atomic number of elements. Okay, so Moseley conducted many experiments and observing the observations which are between nu and z, he given a relation that is nothing but Moseley's equation. Root nu equal to a into z minus b. So here a and b are constants. Okay, z is nothing but atomic number. So how Moseley gets this relation means to constructing Mendeleev constructed periodic table based on atomic weights are the fundamental properties. But instead of atomic weights, Moseley said that atomic number is the fundamental property to construct the periodic table. Okay, so how Moseley given this type of conclusion means he drawn a plot between root nu and z. So this is a plot between, it is a z, it is a root nu, it is a 0. Then you will get a straight line which constantly increases like this. You will get a straight line, means root nu increases, frequency increases, then atomic number also continuously increasing. So he concluded that for constructing periodic table, atomic number is the fundamental property. Based on this conclusion, he proposed a law that is nothing but Moseley's periodic law or Moseley's periodic law or a modern periodic law. Now we are going to discuss Moseley's periodic law. Moseley's periodic law. What is Moseley's periodic law means? The physical and chemical properties of the elements or the periodic functions of their atomic numbers. only one word is modified in Mendeleev's periodic law. Instead of atomic weights, he is taken atomic numbers. So the physical and chemical properties, the physical and chemical properties of elements are the periodic functions of their atomic numbers. This is Moseley's periodic law. So based on this periodic law, Niels Bohr constructed modern periodic law. That is nothing but a long form of periodic law. Now we are going to discuss construction of long form of periodic table. So Niels Bohr constructed long form of periodic table. So based on this conclusion, Niels Bohr proposed a periodic law, and based on that periodic law, Niels Bohr constructed long form of a periodic table, which we are studying now, which contains 112 elements. Nearly 112 elements are present in that periodic table. So this is Moseley's equation, and it is Moseley's periodic law. The physical and chemical properties of elements are the periodic functions of their atomic numbers. Now we are going to discuss, based on this conclusion, now we are going to discuss construction of long form of periodic table. Construction of long form of periodic table. Long form of periodic table. Now we are going to discuss. So it was constructed by Niels Bohr. The long form of periodic table, it is important. It was constructed by Niels Bohr. For constructing this long form of periodic table, he proposed a law that is nothing but a modern periodic law. What is a modern periodic law means? In this Moseley's periodic law, instead of atomic numbers, he is taken electronic configurations. Means according to Niels Bohr, for constructing long form of periodic table, electronic configuration are the fundamental. Elements are the fundamental property. Okay, based on their electronic configuration, he constructed a long form of periodic table, which is similar to Moseley's periodic law. So the physical and chemical properties of elements, the physical and chemical properties of elements are the periodic functions of their electronic configuration. electronic configuration. This is a modern periodic law. Based on this modern periodic law, Niels Bohr constructed a long form of periodic table. Long form of periodic table. Now we are going to discuss characteristics of long form of periodic table. Characteristics of long form of periodic table. Now we are going to discuss. Characteristics. Characteristics of long form of a periodic table. So, Niels Bohr constructed long form of periodic table based on their electronic configuration of the elements. Based on their electronic configuration of the elements. It is represented Hofbauer's principle. Electrons are entossed into ground state orbitals first based on their n plus L values. Already I told you now. So, it is represented. So, what is represented? Long form of periodic table represented Hofbauer's principle. So, it contains vertical columns and horizontal rows. In long form of periodic table, it contains vertical columns and horizontal rows. Okay. It is represented Hofbauer's principle. Okay. It means a long form of periodic table. So, it contains vertical columns and horizontal rows. Vertical columns and horizontal rows. See, vertical columns are called groups. Okay, vertical columns are called groups. In long form of periodic table, there are 18 groups are present. There are 18 groups are present. Okay. So, these 18 groups are divided into 8 A groups and 8 B groups. These 18 groups are divided into 8 A and 8 B. 8 A groups, 8 B groups. Okay. Here, every periodic table starts with first A. They are first A, second A, next third B, next fourth B, fifth B, sixth B, seventh B, eighth B can be divided into 3 subgroups. Eighth B, next first B, second B, after that third A, 4th A, 5th A, 6th A, 7th A and 8th A. It is IUPAC system 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. How many groups? 18 groups are present in IUPAC system. Total 18 groups. In IUPAC named as 18 groups. Okay, in IUPAC means International Union Pure Applied Chemistry, named as 18 groups. Okay, first group it is 18th group. Next, so first A group having only one electron in their valency shell. The group number indicates number of electrons present in the valency shell. For example, so here there are 18 groups are present now. So for example, first A are called alkali metals. What are first A group metals are called? Alkali metals. So here lithium, sodium, potassium, rubidium, cesium, francium are present. Francium, lithium, sodium, potassium, rubidium, cesium, francium are present. Their general electronic configuration is NS1 because they contains only one electron in their valency shell. The group number indicates number of electrons present in the valency shell. Okay, it is a first A. For example, second A called alkaline earth metals. Alkaline earth metals. So here beryllium, magnesium, calcium, barium, strontium and radium. Calcium and strontium, barium and radium. These are elements are present. Okay, here electronic configuration is NS2. Why? Because this group containing 2 electrons in their valency shell. In this group containing 2 electrons in their valency shell. Okay, so beryllium, magnesium, calcium, strontium, barium and radium. So here it is strontium, it is barium and that is radium. Okay, and then here we have to discuss about horizontal rows. Okay, this is a briefly about groups. Next, horizontal rows. Horizontal rows are called periods. What are horizontal rows? Horizontal rows means crossed lines. So crossed lines are called periods. Okay, there are how many periods? 7 periods we have. There are 7 periods in the periodic table. Then first period contains only 2 elements. First period hydrogen and helium. How many elements? Only 2 elements. Okay, 2 elements in the first period. Next, second period contains lithium to neon. How many? 18 elements. 18 elements. So third period contains sodium to argon. How many? 8 elements. Next, fourth period contains potassium to krypton. How many? 18 elements. 18 elements. See, when I am explaining this topic, you have to see long form of periodic table. Then you may easily understand. Then fifth period contains krypton. Then after that rubidium to xenon. Okay, it contains 18 elements. 18 elements. Then sixth period. Here cesium starts with a cesium, ends with a radon. It contains 32 elements. It contains 32 elements. Next, seventh period is incomplete period. Starts with francium and ends with UUB, unibium. It contains only 23 elements. 23 elements. Okay, these are the periods. This is called short period. It is called a very short period. Okay, these two are called short periods. These two are called short periods, and these two are called long periods, and it is a very long period. Very long period. It is incomplete period. It is a incomplete period. This is very short period, first period. Why? Because it contains only 2 elements. And second period is second and third periods are a short period. Why? Because they contains 8 and 8 elements. Fourth and fifth periods are 18 and 18. They are nothing but long periods. And sixth period is the very long period, which contains 32 elements. And seventh period is the incomplete period. This is briefly about periods. These are the characteristics of long form of periodic table, which was constructed by Niels Bohr. So, what is the characteristics means? These are, how many groups are present means 18 groups. How many periods are present means 7 periods. Okay, first period, second period, third period. These represent orbits in the atom. The first orbit contains only 2 atoms, like that. Second orbit, how many? 8. Second orbit contains how many? 8. Third orbit 18. Fourth orbit like this. Okay, this represents half-bow principle. So this long form of periodic table was constructed by Niels Bohr based on MOSELEY'S equation, which gives the relation between nu and z. So he proposed a law that is nothing but the physical and chemical properties of the elements are the periodic functions of their electronic configuration. So these are the characteristics. So when you are going to read this construction of long form of periodic table, you have to keep long form of periodic table aside. Then read these points and see in that periodic table. Then you will get easily. Okay. So this is the way long form of periodic table was constructed by Niels Bohr. Okay. Okay. See, any doubts in this topic? You have to keep aside. Bye.